These notes are a mixed review of the different types of equations that we've covered, Algebra 1 and this year, but we need to be able to solve all the different types no matter when they're presented to us. So in the first one, that's a linear equation. So to solve this one, the first thing we need to do is distribute. So I'll get 3x minus 8 equals 2x plus 10. So now to solve, I'm going to subtract 2x from both sides, and I'm going to save myself some space and do this in one line and add 8, and that's going to give me x equals 18, and there's my answer. Okay, number 2. Number 2 is a quadratic equation, and I know this because of the x squared. When it's quadratic, to be able to solve it, I need to set it equal to 0 first. I also need to keep this x squared term positive, and since it's positive where it is, I'm going to leave it, and I'm just going to subtract 40 from each side. So I have x squared minus 3x minus 40 equals 0. It's a trinomial with a leading coefficient of 1, so I'm going to go straight to my two parentheses. The two numbers that multiply to negative 40 and add to negative 3 would be negative 8 and 5. So what this means is that two things are multiplied together and the answer is 0, which means one of them has to be 0. So either x minus 8 equals 0 or x plus 5 equals 0. So if I solve this equation, I'll add 8 to both sides, so we know that x got to equal 8. Here I'll subtract 5, so x equals negative 5. Now this step right here, I don't ever expect you to write it down. I'm just reminding you of why the answers are what they are. Okay. Number 3. Number 3 is another linear equation, and to solve it, it would just be a lot easier if we could get rid of the fractions, and so we are going to do that. So I'm going to look at this equation and look at the denominators. I have a 3 and 2 and a 3. So the least common multiple of 3 and 2 is 6, and so 6 is what I'm going to multiply the whole equation by. Now I can't leave anybody out, so I have to multiply everything by 6 to keep my equation balanced. So now let's use our shortcut with our fractions. 6 divided by the 3 here gives me 2 times the 2 on top is 4x. 6 times 4 is 24. Over here, 6 divided by 2 is 3 times 1 is 3x. Minus 6 divided by 3 is 2 times 1 is 2. Now that we've gotten rid of the fractions, this is a plain linear equation with nothing that complicated. So I'm going to subtract 3x from both sides, and I'm going to subtract 24, and that's going to leave me with x equals negative 26. Okay, number 4. Number 4 is a radical equation. I knew that because of the square root. So to solve it, I have to undo that radical, and the way we undo the radical is that we square both sides. When I square a radical, it cancels and I get what's underneath. So on the left side, I just have 5x minus 14. On the right, I have x squared. Now the equation is quadratic. So to solve a quadratic equation, we have to set it equal to 0. And when we do that, the x squared needs to remain positive. So since it's positive where it is, we're not going to move the x squared, which means we're going to move the 5x and the 14. Oh, you know what? I made a mistake. This is supposed to be positive 14. So this is plus, this is minus. Okay, we're good now. So we have 0 equals x squared minus 5x minus 14. Well, we'll solve it by factoring. You could also do the quadratic formula. You could graph. You could complete the square, but factoring is the most efficient. So we're going to do that. Two numbers that multiply to negative 14 and 5 would be negative 7 and 2. So x is 7 and negative 2. However, when you're solving radical equations and you have to do so by factoring, it's possible that you'll get what they call an extraneous solution, one that looks like it works but it actually doesn't. So when you're solving the radical equations and you have to factor only on the radical ones, then you're going to have to check your answers. Okay, so when I check my answers, I'm going to take this 7 and plug it into both x's. So 5 times 7 is 35 plus 14 equals 7. So that's the square root of 49 equals 7. That works. That's good. Now I'm going to plug in negative 2. 5 times negative 2 is negative 10 plus 14 equals negative 2. So the square root of 4 equals negative 2. For these problems, square root can't equal a negative, so this one doesn't work. So that means that my negative 2 is extraneous and the 7 works. Okay? It's only on the radical equations for this little review that's going to happen. Okay, number 5. Even though it looks very different from number 3, the idea is the exact same. To solve it as is with those fractions is just not any fun. So we want to clear the fractions. But this time the only denominator I have is x plus 5. So x plus 5 is going to be my least common multiple. So I'm going to multiply everything times x plus 5. The advantage is in the first fraction, those cancel out, and I get negative 4. Over here, I'm going to distribute, and I get 6x plus 30. On the last fraction, they cancel again, and I just get negative 7. Now it's a linear equation, and now I can solve it. But first, to solve it, I need to combine like terms. So this gives me 6x, negative 4 and 30 is 26, equals negative 7. So now I'm going to subtract negative 26 from both sides. So I get 6x equals negative 33. Divide by 6. Unless it's a long problem, I want you to use a fraction. And fractions that are improper fractions are great as long as they're reduced. So let's think, what goes into 3 and 6? Well, that would be 3. Or excuse me, 33 and 6 would be 3. So this is reduced to negative 11 over 2. So there's our answer. Okay, number 6. We learned in the chapter before last, we couldn't solve for the exponent. So to do that, we had to rewrite it as a log. So this is going to be log base 5. Remember, that's a smaller, lower 5 of, and then these two things switch sides, of 124 equals 3x. So now to solve, I have to divide both sides by 3. Now I need to put this into my calculator. So I'm going to go to my calculator, and to do that I need to go to the math menu, and I need to scroll up to option A. So I'm going to have log base 5. Well, I wrote 125, but it's supposed to be 124, right? Of 124, I have to go out of my parentheses, and then I've got divided by 3. As long as you're out of the parentheses, it'll work. For these, we're going to round to 3 decimal places, so that gives us 0.998. Okay, let's do this again for number 7. On number 7, it's really a lot like number 6, except when the base is an e and not a number, instead of doing the log, we're going to do the natural log. So the ln, natural log of 84, equals x minus 6. But to solve for 6, or excuse me, for x, I have to add 6 to both sides. Okay, so when I put that in my calculator, natural log is over here, so I'm going to do the natural log of 84. I have to close my parentheses before I do the plus 6. And my final answer to 3 decimal places is 10.431. All right, number 8. Number 8, we actually can solve this without a calculator. If we write this as an exponent, we can figure out what the answer is. So I'm going to write 3, and remember these switch sides, to the x equals 81. Now x is an exponent, so it's smaller and up high, but everything else is normal sized. Well, if I start thinking about it, 3 squared is 9, that's not right. 3 cubed is 27, that's not right. But 3 to the 4th, oh, that is 81. So the number that makes this true for x would be x equals 4, because 3 to the 4th power is what gives us 81. Okay, this is not printed on there, but I do want to do one more example, because after I printed these notes, I realized there was one more type that I needed to deal with. For these, we did problems like this, and we discovered that if we could write them having the same base, that we could set the exponents equal to each other. So if I think about 8, the only way I can rewrite 8 is 2 to the 3rd. For 16, I could do 4 squared, but those don't match. Or I could do 2 to the 4th. Well, these 2's match, so that's going to work. So I'm going to rewrite this as 2 to the 3rd times 2x plus 5. And over here, I'm going to write this as 2 to the 4th times x minus 9. Now that the bases are the same, now I can set the exponents equal to each other. So I have 3 times 2x plus 5 equals 4 times x minus 9. So now it's linear, and we can distribute. So I get 6x plus 15 equals 4x minus 36. I'll subtract 4x from both sides. So I get 2x plus 15 equals negative 36. Subtract 15 from both sides. So I get 2x equals negative 51, divide by 2, and we're going to leave them as improper fractions as long as they are reduced, and that is my final answer.